Okay, let's do an example 1.8. Okay, you are given a recurrence relation, right? Something we have used before. Now, for this recurrence relation, the question first part asks you to form a conjecture. Okay, so this is not new, right? We want to make a guess, right? How can we write the general term an in terms of n only instead of recurrence relation? Okay, so second part is a verification, which we will talk about this in details later. Okay, let's focus on part one first. Okay, so for a conjecture forming type of question, it is important that we apply a problem solving heuristic, right? So we need to really make a systematic list first by writing down the first few terms. Then hopefully we can recognize some pattern. Right? So this is an essential skill for conjecture making. Okay, now let's start. So the question actually gives you a hint. The question says, please use Power-Sol 2. So Power-Sol 2, of course, if you start from negative power, maybe not very relevant. Okay, we can start power 0 onwards. Okay, so there are some, these are all integer values from 2 to the power 0 all the way to 2 to the power 4. Okay, then at the same time, right, we have previously used our GC to find out the terms, the first few terms in the sequence, right? If not, you can also do it manually and slowly, right? So these are the first five terms in this sequence, right? Hopefully you can compare, right, and find out the relationship and figure out the pattern, right? But if you really cannot, perhaps you will need to write down a few more terms. Okay, so if I do compare, I realize the powers of 2, right, are always one more, right, than the term in the sequence. That's one. Second, I also realize that the power is not exactly the subscript. 2 to the power 0 is linked to the subscript 1. 2 to the power 1 is linked to the subscript 2. So 2 to the power, example, 2 to the power 10, which is, I think you don't know the value, 1024, right, will match with the subscript 11. Right, so the subscript is always one more than the power on top of this difference of 1. So that means an, if the subscript is n, right, it is 2 to the power of n minus 1 and 1 less than the value of power 2. And this conjecture by right should work for all the subscript from 1 onwards. Of course, you can write either n greater to 1 or you can write n is a positive integer. Now, before we move on, it's an important habit that we actually check our answer. How do we know our answer is correct? So this one no need to write in your exam script, but it's a good habit, right? Maybe use draft paper, do a quick check, right? So if n equal to 1, that means my a1 should be 2 to the power 1 minus 1, which is 1 to the power 0 minus the 1, this is 0. Okay, so it matches, right, with the given first term. Of course, if you don't feel comfortable, maybe you want to check n equal to 4 or n equal to 5, right? So a5 by my conjecture should be 2 to the power 5 minus 1 minus 1, this is 15, right? It also matches with the value given. Okay, so most likely my conjecture is correct, so I will keep this as the final answer. Of course, this verification process is incomplete because we only check 2 terms, right? How do we verify that this conjecture is correct for all the terms? So actually, if you are interested, you can actually read out something called this mathematical induction, but which is not in syllabus of H2 Maths, it is in H3 Maths. Okay, so there's another way to verify that this conjecture in part 1 is really correct for all the terms is you just need to verify 2 things. One, you need to verify that this conjecture satisfies the first term. In other words, the initial condition, right? The second one, the conjecture should also satisfy the recurrence relation. Okay, so we do the verification. Okay, so to check whether the conjecture works for the first term, we'll just let n equal to 1, and based on the conjecture, the value of a1 should be 0, right, which is the same as the initial condition given. Okay, so we are done with the initial condition. Okay, now the slightly more challenging part is we need to verify the recurrence relation. So how do we verify the recurrence relation? We need to substitute both an plus 1 and an, right, with the conjecture that we proposed in part 1. So for an, we propose, right, a will just be 2 to the power n minus 1 minus 1. But for the term an plus 1 in the recurrence relationship, right, n is replaced with n plus 1. That's why this power is n plus 1 minus 1, right, which is an minus 1. Okay, so we are supposed to substitute both terms into the recurrence relation, right, and see whether the left hand side and right hand side are equal. Important, right? Please do your work properly as for verification process. Separate your left hand side and right hand side separately. Okay, so be mindful of how you present this working. So I will substitute. First, I will try to find out the left hand side by substituting an plus 1, which is 2 to the power n minus 1. Right, then I start to find out what's the value on the right hand side, which is an plus 2 to the power n minus 1. Okay, and an based on this substitution is 2 to the power n minus 1 minus 1 plus 2 to the power n minus 1. Okay, before I proceed, okay, I'm a bit lost, right? I will look at the left hand side again. Oh, this is my left hand side. My left hand side is 2 to the power n minus 1. That means this is actually something like my goal, right? So in the proof, I know my ultimate goal, right? I know which direction to go to. So that means how do I simplify this expression to this goal? Minus 1 is already there, right? So I will not touch it. It's more about these two, right? So I group them together. This is 2 times or 2 to the power n minus 1 minus 1. Of course, based on integers law, this is 2 to the power n. Then I have done the verification. Of course, for this simple example, you don't need to really think about the goal. Most probably you still can verify left hand side go to right hand side here. But for more complicated identity or more complex identity, I think it's important to understand the goal but you are actually doing your manipulations.